All right, so we've, in this unit, we've started with, very simply, started with length, and area, and then volume, and then mass, and we've talked about how we measure these things, what they mean. Now we're moving on to the last topic, which is density. And density incorporates both mass and volume. Right? And so when we talk about density, the definition we're going to use is the amount of matter in a given space. Or we may say how compact the molecules in the substance are. That's what density is. How much matter is in a given space. So if we think about that definition, the amount of matter in a given space, that incorporates two things we've talked about. What do we call the amount of matter in an object? What word did we use for the amount of matter? Jonathan?
Mass.
Yeah, that's mass. And how about the amount of space? What's that, Jonathan? Volume. Density is the mass in a given volume. Okay? So density is a quantity that we calculate once we know the mass and volume of a substance, of an object. All right, so let's talk about a couple of principles related to density. First one is that for a certain pure substance, aluminum or gold or nitrogen or water, for a given substance, at one temperature, the density of that substance is a constant. For example, at 20 degrees Celsius, the density of pure aluminum is 2.7 grams per cubic centimeter. Okay? And whether it's a big block of aluminum or a tiny little speck of aluminum, its density at that temperature is always 2.7 grams per cubic centimeter. We say that density is an identifying property because if we know the density of a material, it can help us to identify what that material is made out of.
Is that why when you have 4 cylinders and you said that the littlest one was like graphite or something and the biggest one was aluminum?
Yeah, that's aluminum, that's lead, this is maybe tungsten, this is copper, yeah. So each of those types of material has a different density. It's a characteristic of that element. And so it varies. So whether it's a tiny little piece of something or a large chunk of it, doesn't matter. The density is the same. Okay? You know, this aluminum cylinder's density is 2.7 grams per cubic centimeter. Okay? Well, what if I cut it in half? Shouldn't its density be half?
No.
Because when I cut this in half, what am I doing to its mass, Nicole?
You're just making it smaller and the molecules are still the same.
Yeah, I'm not changing how compact the molecules are. If I cut this in half, what is the mass of one piece going to be? Jonathan?
The mass is going to be 1/2 of the whole shape.
And?
But the volume is going to be 1/2, so the density will be exactly the same.
Exactly. This is where I'm going to mention ratio earlier. Is that density is a ratio of mass to volume. And if I cut it, if they both decrease in half, then it's the same ratio. Okay? So, goes along with what I just said. And so if we have an unknown substance, if I just give you a random piece of metal, if you calculate its density, you can then use a chart, which we have in our notes later on, that identifies what the given density for various materials is at certain temperatures. Okay? And so we could use the density of a material to identify what type of material that is. All right. Second, density determines buoyancy and how objects float. A less dense solid, liquid, or gas will float in a more dense liquid or gas. helium is a gas. Helium has a very, very low density. And therefore, helium balloons float in air because helium is much less dense than air. If I have a piece of plastic and I put it in water, if it floats, we know the density of that plastic is less than water. If it sinks, we know the density is more than water. And then number 3. So I said the density of a substance at a given temperature does not change. But what if the temperature does change? Well, that can affect the density of a substance. Temperature does impact it. This aluminum cylinder that I'm holding, if I heat it up, do you know what generally happens to almost all substances when they're heated? Nicholas? They expand. So if they expand, what is increasing?
The volume?
Yes. Is their mass going to change? No, I'm not adding any molecules or any matter to this. So the mass is going to stay the same, but the volume is going to increase. Therefore, what's going to happen to density? Cole?
It's going to change because the molecule is separate.
Yeah. It's going to change in which way? Higher or lower? It's going to get lower. It's going to be less dense because the volumes increase and the molecules are less compact. Heating up a material causes the volume to expand, which causes the density to decrease. And this is, for example, why a hot air balloon floats. In a hot air balloon, they have that big flame inside, that burner. What it does is it heats up the air inside the balloon, causing it to become what? Joey? What's up? Well, the molecules do move quickly, but what about density? Jonathan?
It decreases the density.
Decreases the density of the air in the balloon, make it less dense than the air around it, causing the balloon to float. Okay? You shut off that heat, and the air inside the balloon starts to cool. When it reaches a density equal to the air around it, what will the balloon do? No? If it is an equal density to the air, it'll stay where it is. But then you have to take into account the weight of all the people and stuff in the balloon, and then it'll start to sink when the total density drops. So temperature does affect density. So therefore, when you look on that chart that shows various densities, it tells you this is the density of aluminum at 20 degrees Celsius. Okay, so at that specific temperature, because if the temperature changes, the density can change. All right, so to calculate density, we use a proportion. Okay? The density is the mass of the object divided by the volume of the object. Okay, density is a measurement of how tightly packed the molecules are, how much mass is in that given volume. And so, like we just said, size doesn't matter in terms of density, because if you have 10 times as much, its volume is 10 times greater, but so is its mass. So the ratio doesn't change. Okay, and like we said, various materials have certain densities. The most dense solid is called osmium. Okay, it's a very hard metallic, sort of bluish-white metal, densest substance on Earth. Okay, so the question is, why is lead? So we have two metals, aluminum and lead. Lead is much more dense than aluminum. But why is it more dense? What's different about lead versus aluminum? Eli?
The aluminum is very spread out and that's why it's longer, but the lead is packed into one small space.
Yeah, there's two factors here. One is how tightly packed the molecules are. So the atoms of aluminum have some space between them, whereas the atoms of lead are packed closer together. The other factor that comes into play is the actual mass of the atoms itself. Different elements the atoms of those elements have a different mass. It's called their atomic mass. And lead has a greater atomic mass than aluminum. So each individual atom has a higher mass and they're packed tightly together. Gold is another material that has a pretty high density. In fact, that's one of the reasons why gold was often used as a currency. First off, it's common enough that there's a fair amount of it around, but rare enough that it's not everywhere. The other thing is its density is very high. It's 19.3. So you can pretty easily, if you had a piece of pure gold in your hand versus a piece of some other metal that looks like gold, or gold mixed with another metal diluted, you could pretty easily tell the difference in the density because you could feel them. Gold will feel very heavy compared to another metal. And so they can use that to figure out if something is pure gold or if it's not. Emma?
If you dilute pure gold that's like 24 carats to make it 18 carats, does that change the density?
Yes, because basically you're mixing two metals together, making alloy, multiple metals, and then you no longer have a pure substance. Okay. All right. So let's look at an example here. So a man goes in with a gold nugget to buy a suit. He's got a nugget of gold. Okay. He wants to use this nugget of gold to buy his suit. The owner of the store says, okay, fine, I'll take the gold, but I want to be sure it's real. So he has some tools. He measures its mass to be 47.9 grams. He measures the volume of this chunk of gold. It's 3 cubic centimeters. Is it pure gold? You calculate its density first of all. Go ahead. Calculate its density. Okay, so we know density is mass divided by volume. So what did you get for the density of this gold nugget? Chloe?
15.96.
Okay, so is this gold? Sure. Emma?
No, because it's not 24.
Well, what is the density of gold? Morgan?
19.3.
So is it gold? No, it is not. So again, we divide the mass, 47.9 grams, by the volume, 3 cubic centimeters. This gives us 15.97 grams per cubic centimeter. No, that's not gold. Pure gold is a density of 19.3 grams per cubic centimeter. Probably it's gold mixed with some less valuable metal. All right, let's look at some more examples. So we know to find density, we need mass, we need volume. And so some of the problems that you'll solve, you'll have to calculate the volume, or calculate the mass, and then figure it out. Did you have a question, Jeff?
Yeah, how do you know what to label density?
Good question. Yeah, what we do with our numbers, we do with our units. So we have grams, we have cubic centimeters, so it's grams per cubic centimeter. So what that means is each cubic centimeter of this material has a mass of 15.97 grams. Okay, so it's telling you how much mass there is in a given volume. All right, so again, formula for density is mass divided by volume. So here I have a cylinder, and I give you some information about that cylinder. You go ahead and calculate its volume and then its density. your own calculator every day. All right, start with volume. So what do we have here? What's our formula? Jonathan?
Pi times radius squared times height.
Pi times radius squared times height. What is the radius, Jonathan?
1.5.
Okay, the height?
7 centimeters.
And what do you give for an answer?
49. 4, 6.
Okay. 49.5, we'll round, cubic centimeters. Did we get that? Yeah, we can round here. All right, now we need to calculate its density. So we have our piece of information we need now. We have the volume, we have the mass. So what do you get for the density of this cylinder? Bianca?
10.5 grams per cubic centimeter.
Yes. 10.5 grams per cubic centimeter. The mass, which is 519.75, divided by the volume, 49.5 cubic centimeters, gives us the density of 10.5 grams per cubic centimeter. Again, what this means, each cubic centimeter of this material has a mass of 10.5 grams. You understand how to calculate density? Yeah, it's just breaking it down. Find the mass, find the volume, and then divide. All right, let's do another example. Now I have a rectangular prism. Same thing, please find the density. All right, Nicholas, what do we need first? Find the volume. How did you do so?
15 times 5 times 6.
Okay, and what do you get?
150 centimeters.
100 and what?
150 centimeters cubed.
Okay. 450 centimeters cubed. The mass, we know, is 770 grams. What does that give us for its density? Joey?
1.7 grams per centimeters cubed.
1.7 grams per cubic centimeter. So this material has a density of 1.7 grams per cubic centimeter. And we know that density is an identifying property. We can use, if we don't know what type of material this is, we can find its density and then determine it. Does anybody know what material this is? Jonathan, you know?
Magnesium?
How'd you know that?
Because I looked at the chart below.
He looked at the next slide, which lists the density of some common materials. If we look down, 1.7 is the density of magnesium. At 20 degrees Celsius, magnesium pure magnesium has a density of 1.7. Notice it tells you at certain temperatures. These are liquids and these are gases. Obviously, gases are much less dense than liquids, most liquids, and solids. All right? Any questions about that? So let me ask you a question. Are there any metals that could float in a liquid? Sachin?
Yeah.
What?
Pine wood and balsa wood.
Those aren't metals. Those are woods. But they would float on most of those liquids. What else? Courtney?
Magnesium.
Magnesium would float in what?
Mercury.
Yeah, it would float in mercury. Emma?
Everything lead and under can float in mercury.
Yeah, mercury is a very, very dense liquid. In fact, a chunk of lead, a very dense metal, would float in mercury because mercury has such a high density. All right, we'll talk more about buoyancy, though, next week. But for now, we're going to move on and start to talk a little bit about solving some problems. Correct?
On the slide before, it said density is known as a length property.